So in the previous set of videos we were looking at, we had scraped some PDFs and we had cleaned the data, tokenized the data, and we had looked at word counts and created word clouds. Now let's do that same application, but this time let's do it with a data set that is the survey results. So in other videos, we've looked at our bargaining survey results. So we designed a survey to collect information from union members as we prepare for collective bargaining. And so then we, in previous videos, cleaned that survey. And this is the cleaned version. It is not the coded version. So notice as we look at it here, it is text. It is not the fully coded version where it's all numbers. So you can find this particular data set, if you don't have it already, in your Google Drive. You can find it here on GitHub along with this package. So we are here at drstephpowers.github.io/BIA, and we are doing text mining. And you will find here as well the data sets where here's bargain numeric. Click on that, click the download button on the right, and put it into your Google Drive. And then here is our code we can open in Google Colab. So then if we're going to do this, make sure that you have connected this workbook to your Google Drive so that you can then load in that data set. So again, we're doing pd.read_excel. So you have to have already imported pandas as PD. This particular file I have put into my Google Drive. So it is in the folder BIBA handbook and the folder inside that called chapter 4. If you're doing this for yourself, this part you can leave as is. And then this back half is just the folders that you put it into. All right, so pour it in and we can just take a quick look at it. As we saw before, this is not the coded version. It does have text. And here, the ones we're going to care about are the open-ended questions in this survey. So for example, question 16 is where they could write in any text that they want. So let's analyze those responses. Now, one of the first things we need to do is we need to specify that this type of data is a string. So what we're going to do is we're going to do data frame question 16. So that's the column called question 16 is going to be a string type. And so that's what this is. So we're just labeling it here as a certain data type. Make sure that it's set properly. And then what we're going to do is we're going to turn this into text. In this particular case, we don't need to have separated each person's response. We just need everybody's responses squished together in one text. So what we're going to do is we're going to join all of the answers in the data frame question 16. So technically you see answer for answer, that means it's a loop. We're going to create a loop and we're going to go through everything in question 16 and we're just going to join it all together. Okay. So we're going to create a single set of text that joins together all the responses in question 16. And you don't have to write that this is answer for answer. You could make I for whatever these just need to be the same thing here. You can call them whatever you want. They're just placeholders for each particular row in question 16. So when we output this, what we get is we get everybody's responses all merged together. Okay. And that's because if we want to do a word cloud and a word count, in this case, we're not trying to see if there's a difference between one person's statement and another. Here, we're just trying to see what are they all generally saying. So we're going to do word clouds for this. And so here we have our text all smushed together. And we need to import matplotlib.pyplot as PLT. And then we're going to do from word cloud, import word cloud, and use the word cloud stop words. So the difference between this example and the previous ones is because we don't have to clean this and because we don't have to tokenize this for other purposes, we can just use this giant set of text and the pre-built tokenization that's inside the word cloud package. So that means we'll just use the stop words that are in the word cloud package. So rather than, as we did before, where we separated it out and used the NLTK package to do it, Here we're just skipping all of that because all we're trying to do is build some word clouds. And ultimately what we'd like to do is do some comparisons, create a word cloud for the part-timers, create a word cloud for the full-timers, see how it looks differently. So since we don't need those tokens for other stuff, we'll simply just use all the built-ins inside of word cloud. All right, so import matplotlib.pyplot as PLT from word cloud, import, capitalization matters, W and C are capitalized here, and then stop words, complete capitalization. Now, you can add additional stop words. So when we first look at this here, automatically we see that there's an issue because there's some people who didn't write in a response to question 16. So theirs was empty, and so when it was put into Python, it showed up, that empty cell got labeled as a NaN. So what we're going to do is add to our stop words list NaN, because we don't need that. That's not relevant, and we don't want our word cloud to say NaN is the biggest appearing word, because that just means that most of your respondents didn't answer the question. We want to remove that and look at what people are actually saying. So stop underscore words equals, and then here whatever you want to remove plus the list of stop words. Okay. So this lowercase stop underscore words is what is going right here. So we call the function word cloud. Our stop words are going to be stop underscore words that we listed here. Our background color is going to be white. And we're going to do word cloud.generate. And then notice here, we didn't have to say it's a dictionary. We didn't have to say, let me just go back in time here. See how this said generate from frequencies? That's because the way our data was set up is it was a dictionary that had the text and the corresponding frequencies. So if you're entering in your word cloud from that word count, then it has to have generate from frequencies, dictionary, WC, or whatever you've called it. In this case, because we're doing it all inside the word cloud package, what we're going to do is just have our text here. And then all we do is say generate from this text. Okay. And the rest of this looks the same as before. So what we see here in this particular question is that work and hour, opportunities, provide, flexibility, childcare, these are popping out at us. Okay. So when we're asking people what they need, they seem to be related to work, probably related to the flexibility of work. Here we have pay. So where we want to do then is we want to see, we look at this information, some of this like opportunities, maybe this is the part-timers who want more opportunities, more work, more hours. But we also want to separate out those who are full-time. They probably don't want to work more hours, but maybe they're the ones who want leadership, mentoring, flexibility, childcare, parking. We want to differentiate between different groups within our bargaining unit because maybe those groups have different needs. And so we can get from our word cloud those general themes. So maybe here first, though, before we break it up into part-time and full-time, we could decide to get rid of more words. If the question, for example, is what do you need in your work, then we would expect work to appear a lot. And maybe that's not so relevant because it was part of the prompt, part of the question. So here we can add work to the stop words and then do it again. So remember, it's just going to pull from the stop words, the ones we've added plus the ones that are already there. And so you can see it makes work go away. And now we have hours, provide, flexibility, opportunities appear much bolder. Okay. All right. So as I was saying, let's create two different word clouds, one that's part-time and one that's full-time. So what we're going to do is we are going to take that question 16. We want to make sure that question 16 is a type recognized as string. Okay. Then what we're going to do is we're going to separate into two tables here. One where question 2 is equal to part-time and one where question 2 is equal to full-time. This is the non-coded data set, so it's not, group 1 and group 2, it is actually still labeled as part-time and full-time in the data set. And so we would then expect this to be the one that would appear in the table under question 2. So let's call this data frame 1 and data frame 2. You can call it whatever you want. Call it part-time, call it full-time, PT, FT. I suck at numbering, labeling, so my labels are super boring. Data frame 1, data frame 2, data frame 307. So here what we have is we're going to then just create group 1, group 2. Group 1 is the part-timers, group 2 is the full-timers. Then what you're going to do is take all the responses from data frame 1, which is your part-timers, and smush together all of their responses. So answer for answer in data frame 1, question 16, join them all together. Okay, just putting a space in between. All right, text 2. That is going to be the data frame 2. That's the full-timers for question 16, answer for answer, join them all together into a single text. Now let's create our word clouds. Let's create a word cloud for text 1 and create a word cloud for text 2. You can have the same set of stop words for both of them. So right now, because we haven't changed it, the stop words are removing NAN and removing work, and then removing the A is the and, that kind of stuff. So unless you specify differently, it's the one we ran before. So if we look at the needs of the part-timers, the needs of the part-timers is that they need hours, they need childcare, they need flexibility. Looks like they say guaranteed, so probably guaranteed hours. Right, so we can see some of the comments from the part-time. Let's compare it to the comments from the full-time. So notice this code is the same, except for it says text 2. And that text 2 is simply the data frame 2, which was the full-time. All right, run this one. All right, so flexibility shows up in this one, as does childcare as well. So we can see that that's a commonality that appears for both groups. Leadership, location, shift, flexibility, night. So maybe they want some ability to determine whether they work night shift or not. Technology. So we can explore then, and we will in later videos, we could say, oh, well, this is a key word, an interesting word, night. So what we can do is then we can use our tokenization and we can say, go find night, and then pull up all of the comments related to that to help us get an understanding of what people are saying about night. So we'll do that in a future video.